Okay, hello everyone. This is my second lab work from the course Computer Vision. So let's start the video from the reading assignment number 2. So we need to create an algorithm that identifies image similarity using image histogram. So this is how normal histogram looks. And so we can start from importing the all needed libraries: OpenCV, NumPy, Matplotlib. And next step, we are just importing these two images. I have flag and flag2. So we import this image. We're reading it into an array, and then we're using CVT color function in order to convert it from PGR format to HCV format. So why do we need this? If we look at this image, we can see that it is colored image. It is not gray, black and white image. So it has 3 channels: blue, green and red. So in order to compute, it is hard to compute 3 channels. We can decrease this amount of channels. So now in HCV format we can just use hue and saturation. This is the most valuable channels. So we are making the same actions with the second image. We are reading it and converting to HCV. So here I have some variables that I will explain later. So hist image 1. We are using function calc_hist, which will calculate histogram, which takes the image itself as the first argument. So the second argument, it is the array which contains the number of channels. So here, as I said before, we have just 2 channels, which is hue and saturation, and we are using 0 and 1. The third argument, it is mask. Mask, it is when you want to create a histogram from not the whole image, and you want to create a histogram from only the one part or one piece of that image, you can use the mask. But here we doesn't need it, and we just make it none. So the next one, it is histogram size, 180 and 256. So it means that we use this number of bins per each dimension. So hue varies from 0 to 179, saturation from 0 to 255. So this means that we use 180 bins for the hue and 256 bins for the saturation. And the last one, it is ranges. Here I wrote this the same values from 0 to 180, and the saturation ranges from 0 to 156. And then it is used to be these values which will be measured per each dimension. Then we are using function normalize in order to normalize our image, our histogram image. For example, we have here the source and destination. This alpha means the minimum value, beta means the maximum value, and norm, min, max, it do some magic using scaling and shifting, and that's all. Yeah, we're just normalizing. So we're making the same actions with the second image, also calculating the histogram and normalizing them. So at the end, we compare these two histograms with the function compare hist. So the first argument is the first histogram, the second argument is the second histogram, and the last argument it is the method, the type of comparison. We have some different types of so we have some methods for different metrics to compute the matching. So it is correlation, chi-square, intersection, and Bhattacharya distance. So I choose the first one, correlation, because in the end of this reading it gave the best results when the image when it is the same image, when it is comparing the one image with the half of it, and etc. So I choose correlation. Here this is the formula, but we can just use this CV2 the hist compare curl, and it makes computation of this formula. And then so let's run this code. It gave us 37% of the similarity of those images, these two flags. So, or if we want to compare two exactly same image, we will see what does it do. So similarity is 100% because we are giving the two absolutely equal images. So this is it. This is the end of the video, end of the assignment. Thank you for your attention. Yes, goodbye.